All right, AP Calc, back for part 2 of this section 1.3 lesson 1 video. Look at the directions on number 13. It states, if theta is in the standard position and Q is on the terminal side of theta, find the values of the trig functions of theta. So Q, we have to assume is a point. So here's 4, -3. It's on the terminal side. Terminal means end. It's on the ending point of a ray that rotates all the way to that point. So think about it like this. You've got a ray, and then it rotates all the way around and ends here. But think of it like this. It's always anchored in the origin. So it actually is still a ray that's pointing that way. So here's what it does. This theta could either be traveling this way or all the way around. But this is called its reference angle. We talked a lot about reference angles back in the day. And what we can do is we can use this reference angle with our understanding of negative direction to kind of piece this together. So here's what we got. We've got a positive side, or a positive 4 side. We've got a -3 side that creates our 90-degree angle with the x-axis. And then we've got a hypotenuse of 5. You always give your hypotenuse sort of like neutral direction, so we're always going to keep that hypotenuse as 5. Okay, so that's kind of what they were asking you to do. They were saying, figure out where you're supposed to be in the xy plane, and then from there you can find all 6 trig functions from there. So then your sine would be opposite over hypotenuse, -3/5. Your cosine would be adjacent 4 over hypotenuse 5. Your tangent would be opposite -3 over +4. And then again, you got all the others that basically just flip the fraction, yeah? So cosecant of theta equals -5/3. Secant is 5/4. And cotangent is -4/3. It's kind of like the same instructions are given to you on 15, but they're just giving you much different information to go from. So they're saying that you guys are in the specified quadrant 3. 1, 2, 3, 4, right? And it says it's parallel to the line 2y minus 7x plus 2 equals 0. And they want us to find the values of the 6 trig functions where it lives. So, all right, what does it mean to be parallel to a line? Well, in equation format, it just means, hey, you got the same slope. So this one, we can determine the slope by isolating the y variable. Y equals mx plus b. Add the 7x, subtract the 2x. Divide by 2, and you get y equals 7/2 x minus 1. So our terminal side is in quadrant 3. We know that if it has a terminal side in this quadrant, then the ray had to rotate from it emanates from the origin. So it's kind of like, hey, you got a line that's parallel to that one, it's going to be the line that goes through the origin. So it goes through the origin with a slope of 7 over 2. But instead of going up 7, right 2, you're going to have to go down 7, left 2, because it's in the third quadrant. So down 1, 2, 3, 4, 5, 6, 7, and left 2. So I could use a ruler to make that nice and straight, but I didn't. There we go. This is sort of how it travels, but this is the theta that we're talking about. So you had to go down 7 and left 2 to make this situation happen. So those are both negative directions. Left is negative, down is negative. Hypotenuse is always neutral, though. So I'm going to ignore the negatives for now because I'm just looking for a positive value right here. 7 squared plus 2 squared equals our unknown squared. So that's 49 plus 4. It's going to be 53, and then you take the square root of it. Got it. Now, do we have to find all 6 trigs? All 6 trig functions? Yeah, we do. But this is kind of an easy task at this point. It's not really like mind-bending work. So, well, let me give myself some room. So there's our root 53. All right, sine of theta is opposite negative 7 over root 53. All right, quick, quick skill check. To rationalize this, you would multiply the top and bottom by root 53. So you get negative 7 root 53 divided by 53 for the final answer of sine. Make sure you still got that skill intact. Cosine would be negative 2 over root 53. And again, multiply bottom and top by that, and you get kind of a similar structured answer there. Similar format, at least. Tangent of theta would equal opposite over adjacent, negative 7 over negative 2, which is 7 halves. And then we could just find the flips of those as well. You know what? Just for time purposes, I'll let you guys find the inverses of those, and really it's just a matter of flipping them. And I would flip them from the original statement. Otherwise, you're going to have to do that rationalizing thing again. But, okay, here's what I mean. So I guess I will do these as well. Cosecant would make way more sense to just say flip root 53 over negative 7. And now I don't have to find a new rational denominator. Do the same thing with this, root 53 over negative 2, and that's just 2 sevenths. All right, and 17, and really 19, we've got some interesting directions that you were never asked before to do in calculus, the pre-calculus. So let's do it now. So 17, the directions are, if theta is an acute angle, use fundamental identities to write the first expression in terms of the second. Here's the first expression. How do we write it in terms of sine only? Well, first we need to establish what they mean by fundamental identities. And they do that in the textbook in the reading on page... What page was that? Page 30. So they are viewing the fundamental identities as the pi identities. Sine squared plus cosine squared equals 1. 1 plus tangent squared equals secant squared. And 1 plus cotangent squared equals cosecant squared. I called those pi identities back in the day. They also show the reciprocal identities, which are like, hey, 1 over cosecant equals sine. Or vice versa. You know, the whole idea that when you flip a fraction, you get sort of like that opposite part. That's what they mean by fundamental identities. Go to 30 if you need to like reinforcement in that. All right, so what do they mean by rewrite that whole thing in terms of sine? Well, we got to start with cotangent. Cotangent, remember all those strategies back in the day? Turn them into sines and cosines. That's exactly what you're going to do right now. Cotangent ends up being cosine of theta divided by sine of theta. Is there any way to make cosine look like sine? Well, there was that one formula. That one formula that said sine squared. Here, I'll put it over here. Yeah. Sine squared of theta plus cosine squared theta equals 1. We always had that in our back pocket when we were proving things or trying to make an equation work out right. So what if we got cosine by itself? What if we solved for cosine and then just plugged whatever the result was right in there? I'm doing it. So you subtract the sine squared from both sides. You get cosine squared of theta equals 1 minus sine squared theta. Square root both sides. And cosine equals root 1 minus sine squared of theta. Now, am I including the plus or minus in there? It doesn't seem like in the textbook's answer key that they did. I think it's because they said it has to be an acute angle, so it's restricted to the positive places where cosine and sine live. And I'm sorry, you couldn't see that whole thing, could you? My apologies. So cosine of theta is equal to the positive version of 1 minus sine squared, the square root of that, because it's an acute angle and must live in the upper right first quadrant. So yeah, plug that in for cosine, and you have successfully written cotangent in terms of sine. I'll show you one more from number 17. Part B says go from secant to sine. So to go from secant to sine, we first got to, well, I don't know, what should we do? We can make secant into, I mean, we could just make it 1 over cosine, couldn't we? And then just do that. I mean, that's a little bit boring, though, right? We know what cosine is already. Why would we do it again? I guess for convenience. Some people like that. And if you wanted to rationalize it, make it so that there's no root on the bottom, multiply the top and bottom by root 1 minus sine squared, which would equal root 1 minus sine squared on top divided by the rootless 1 minus sine squared. Yeah. Okay. The last section, I kind of just want to leave to you guys. I'll give you one example, and that'll be number 29. So look at 29. They're saying find the tangent of 5 pi over 6. All right, I need to find an eraser. You see that? Tangent of 5 pi over 6. Now we're saying you need to be able to do this without a calculator. Like a calculator could give you decimal answers all day long. What I want you guys to be able to show me is that you know that 5 pi over 6 lives in quadrant 2. That 5 pi over 6 is a 30-degree reference angle. And it corresponds to the unit circle value, negative root 3 over 2, 1/2. And that tangent is the y-coordinate divided by the x-coordinate because it's sine and cosine. So what I'm going to leave to you guys and not make a bunch of not make any more videos about is the unit circle is kind of up to you. You know, go back, review that stuff. There's a lot of resources. And make sure you can deal with, yeah, I know what tangent is. it's negative root 3 over 3 when I do this calculation. If you're worried about that and want some in-person instruction, just let me know. All right, guys. Thanks for watching. I'm done with videos for today.